Welcome to the deep dive. Today, we're getting into the absolute foundation of, well, almost everything digital now, the cloud. We're going to be breaking down the core concepts from the AWS Cloud Practitioner Essentials, specifically Module 1.
And the goal here isn't just to, learn a few new terms. We're really trying to shift how you think about computing itself. If you're still picturing a PC on your desk or a server rack in a closet, that's a bit outdated.
We're talking about a completely different era, the era of having a virtual supercomputer that's just on tap whenever you need it.
Exactly. And that changes everything. So today we're focused on 4 key pillars from that material. First, we'll get into what the cloud actually is and the huge economic shift it represents.
Right. Then second, we'll try to visualize the sheer scale of the AWS Global Infrastructure. I mean, how they physically build this thing to be so resilient.
After that, we'll hit the core benefits, but we're going to really zero in on 2 of them, elasticity and agility. Those are the real game changers.
And finally, and this one is crucial, we are going to nail down the security concept known as the shared responsibility model.
Yeah, if you use the cloud at all, you absolutely have to understand that distinction. It's non-negotiable.
Okay, let's do it. Let's start with the basics. What's the official textbook definition we're working with here?
The precise definition from the source is that cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing.
Okay, on demand and pay as you go. That phrase right there, that's the whole revolution, isn't it?
It is. Before the cloud, a company had to guess. They had to estimate their absolute peak usage, Black Friday, maybe some big launch event, and then buy all the physical hardware to handle that peak.
Even if that pick only lasted for, what, a few hours a year?
2 hours a year, exactly. They were locked into what's called a capital expenditure model, a CapEx model.
So they're spending, it could be millions of dollars up front on servers, on storage.
And not just the servers. They had to pay for the building to house them, the power, the air conditioning to cool them, the specialized staff to maintain them, and the security guards to protect the building. 24/7.
So you're paying for 100% of your capacity, even when you're only using, say, 10% on a quiet Tuesday morning. It feels like buying a massive warehouse just in case you need to store one extra box.
That's a perfect analogy. And all of that stuff, the racks, the cooling, the networking, AWS has this great phrase for it. They call it the undifferentiated heavy lifting.
I love that. Undifferentiated, because none of that work gives you a competitive advantage, right? No customer is going to choose your product because you're really, really good at managing your server room's air conditioning.
Precisely. It's just work you have to do. So cloud flips that whole model on its head. It moves you to an operational expenditure, or OpEx, model.
And that's where pay-as-you-go comes in. The classic analogy is electricity, right? You don't build your own power plant. You just flip a switch and pay for the electricity you use.
Exactly that. You're turning those huge, fixed, upfront costs into variable costs that scale with your actual usage.
Okay, but let me push on that analogy for a second. With electricity, I still own the house. I own the light bulb. But with things like serverless computing, it feels like I don't even own the virtual light socket anymore. Where does the analogy break down?
That's a really sharp point. The electricity analogy is great for the basic concept, but you're right. It implies you own a fixed asset, like your server. Serverless is more like paying a tiny fee every time you use a shared coffee machine to make a cup of coffee. You don't manage the machine at all.
You just show up with your coffee grounds, which is your code.
Exactly. You just provide the code. The economic model becomes even more granular. You pay per millisecond of compute time. It's an incredible reduction in waste.
It really is.
Yeah.
Okay, so from economics, let's go to the practical side. The client-server model. The source uses a coffee shop analogy, which I think is pretty helpful.
Right. It's the most basic concept. You, the person listening, are the client. You make a request. In the coffee shop, it's for a latte. On the internet, it's for a web page.
And the barista's the server.
Yes. The barista takes your request, checks if they can fulfill it, do they have milk, is your credit card valid, and then they make the latte and hand it back to you. That's the response.
Simple enough, but here's the classic problem. What happens when a tour bus with 100 people pulls up outside, all at once?
Well, in the old model, your on-premises data center, your one barista, your one server, would just get overwhelmed. It would crash.
That's the 503 service unavailable error we all love to see.
That's the one, because you only had a fixed amount of capacity.
Right.
But in the cloud, you get this core benefit called elasticity. The system sees that huge spike in demand, and without you doing anything, it automatically puts 10 more baristas behind the counter.
It adds 10 more virtual servers to handle the load.
Instantly. And Just as important, and this is the part people sometimes forget, is what happens when the tour bus leaves.
It scales back down.
It scales back down. Those extra 9 or 10 servers are shut down automatically, and you stop paying for them the second they're off. That rapid two-way automated scaling. That is true elasticity.
And this leads right into what I think is maybe the biggest single advantage, especially for new companies: agility.
Oh, absolutely. Agility is the freedom to experiment, the freedom to fail, but to fail cheaply.
What do you mean by that?
Well, think about the old way again. If your team had an idea for a new feature that needed, say, a special kind of database server, what would that involve?
Oh, months of meetings, budget approvals, procurement, ordering the $10,000 machine, waiting for it to be delivered and installed.
Right. And with all that time and money invested, there's this huge psychological pressure for the experiment not to fail. If it does, someone looks bad, and you're stuck with a very expensive paperweight.
So innovation slows down, people get cautious, they only bet on the sure things.
Exactly. But with cloud agility, you can spin up that exact same virtual database server in about 3 minutes. You run your experiment for a couple of days, and if it's a total flop,
You just turn it off.
you terminate the instance, and your total cost for that entire experiment might be, I don't know, 50 cents.
50 cents versus $10,000 and months of political pain. That changes everything. It's why you hear about this fail-fast culture. It's only possible because the cost of failure has been almost completely eliminated.
It revolutionizes product development.
Yeah.
Instead of big, risky quarterly releases, teams can deploy dozens of small changes a day, see what works, and react instantly. That speed is what agility is all about.
So that's the promise. But what's the actual physical machinery under all this that makes it possible? I mean, to rent a supercomputer for an afternoon, the scale must be just mind-boggling.
It is. The AWS Global Infrastructure is immense, and it's built on a 3-tier hierarchy. It's all designed for 2 things: speed and resilience.
Okay, break down those 3 tiers for us.
So at the top, the biggest unit is the region. A region is just a physical, geographic location in the world. Think Northern Virginia, or Tokyo, or Frankfurt.
And why would I pick one region over another? Is it just about speed?
Speed is a big part of it. You want your servers close to your users. But another huge factor is data sovereignty. A European company might be legally required to keep all its customer data physically inside the EU. So they have to choose a region like Frankfurt or Paris.
That makes sense. It's a compliance thing, too. So if I pick the Tokyo region, is all my stuff just in one giant warehouse building in Tokyo?
Absolutely not. And this is probably the most critical part of their design for resilience. Every single region is made up of multiple isolated locations called availability zones, or AZs.
And when you say isolated, you mean really physically separate?
Oh, yeah. An AZ is one or more data centers, but each AZ in a region is separated by, often, many miles. They're on different floodplains, connected to different power grids, different transit providers.
So they're independent failure zones. That's
Yeah.
the point, right?
That's the entire point. If some localized disaster happens, a fire, a flood, a major power outage, and it takes out an entire AZ.
The other AZs in that same region are completely unaffected and can just pick up the load.
Precisely. That's how they can guarantee high availability. It's redundancy, but on a massive geographical scale.
Okay, so regions for location and compliance, AZs for resilience. What's the third tier?
Those are the edge locations. Think of them less like a full data center and more like thousands of tiny little outposts scattered all over the globe in major cities.
And they're not for running my main application.
No, not for core computing. Their job is to cache content. They hold the finished product, the video file, the images on your website, and keep it physically closer to the person trying to access it.
Ah, so when I'm watching a movie and it starts instantly with no buffering, it's not streaming from a big data center in Virginia. It's probably coming from an edge location in my own city.
You got it. It's all about reducing latency. Services like Amazon CloudFront use these edge locations to make the end-user experience feel incredibly fast.
Okay, this is great. We've got the economics, the architecture. Let's pivot to the thing that makes everyone nervous: security. This is where I see people get tripped up all the time, especially if they're new to the cloud.
The shared responsibility model. It is the single most important security concept to grasp. And yeah, ignoring it is where things go wrong.
It's all about drawing a clear line, right? What AWS is responsible for and what I am responsible for.
Exactly. It splits security into 2 parts: security of the cloud and security in the cloud.
Let's use that house analogy. It makes it really clear. AWS is the home builder.
Perfect. AWS is responsible for security of the cloud. That's their side. They secure the physical data center, the concrete walls, the fences, the security guards, the cameras. They secure the hardware, the networking, and the virtualization software that runs everything.
So if someone breaks into a data center and physically steals a hard drive, that is 100% on AWS. They failed to secure the building.
Absolutely, that's their job. But the second you launch your virtual server on their platform, you've become the tenant moving into that secure building,
Yeah.
and the responsibility shifts.
And now we're talking about security in the cloud. I'm responsible for everything I do and everything I put inside my own apartment.
Precisely. You are responsible for securing your operating system. That means patching it. You're responsible for your applications, for configuring your firewall rules, and for managing who has access. And, critically, for your data itself. You have to encrypt it.
Okay, but let me ask about a gray area. AWS gives me all these tools, right? Like a firewall configuration tool. If I mess up the configuration of their tool and that leads to a breach, where does that fall?
That is a fantastic question because that's where people get confused. AWS provides you with a really strong, secure front door and a high-quality lock, but you are responsible for making sure you actually lock the door.
So if I misconfigure the firewall rule, if I basically leave the front door wide open, that's on me.
That's on you. That is a failure of security in the cloud. AWS can't reach into your virtual server and patch your operating system for you or manage your passwords. They give you the tools, but you have to use them correctly.
It's a bit scary, honestly. It means my own mistake could totally undermine the billions of dollars they spend on physical security.
It requires you to be vigilant, yeah. But the model is clear. AWS secures the foundation. You secure everything you build on top of it.
Okay, let's bring this all home. We've talked about these huge abstract ideas. What does this democratization of computing power actually look like in the real world?
I think the best examples are in fields like scientific research, genomics, pharmaceutical discovery, things like that. Imagine a small biotech startup. They're trying to run a massive simulation on how a protein folds. This requires an insane amount of computing power.
In the old days, they'd need to raise, what, $50 million just to buy and maintain a supercomputer, a high-performance compute cluster.
Right. It was a barrier that was impossible for most to overcome. Now, they don't buy anything. They write their code. And when they're ready to run that simulation, they can spin up tens of thousands of processors, a temporary supercomputer, for maybe 3 hours on a Tuesday afternoon.
And when the simulation is done,
They shut it all down. The billing stops.
yeah,
The total cost might be a few $100s. They've completely sidestepped the need for capital. The barrier to entry is gone.
that's
Yeah.
a revolution in how science can be done. It's not just about business anymore.
Not at all. It lets small, brilliant teams in resource-starved fields compete directly with the biggest government labs and corporations in the world. It's a total leveling in the playing field.
Okay, let's lock these ideas in for everyone listening. We've got 2 quick scenarios. Ready?
Let's do it.
Scenario 1, you're launching an app and you find that your users in Australia are getting a lot of lag, high latency. What's the first, most basic infrastructure decision you need to make to fix that?
Easy. You need to use an AWS region that's physically located in Australia, like the one in Sydney.
Yeah.
You have to place the computers closer to your users. That's a decision at the region level.
Perfect. Okay, scenario 2. A hacker gets into your database server on AWS and steals customer data. The investigation finds they got in because you stored user passwords in plain text, not encrypted. Who is responsible for that breach?
That is a classic example of security A in the cloud. That's on the customer. AWS gave you a secure server in a secure data center, but you, the customer, failed to properly secure the data you put on it.
Nailed it. So, to recap, we define the cloud as on-demand, pay-as-you-go IT. We saw how agility changes the game for innovation. We mapped out the global infrastructure regions, AZs, and edge locations, and we drew that critical line for the shared responsibility model.
And if you think about that last application we discussed, the power for anyone to rent a supercomputer, it leaves you with a really interesting final thought. If the massive cost of computation is no longer the barrier, what huge global problem that we've always thought was just too complex to solve suddenly becomes solvable?
A great question to think about. Thanks for joining us for the deep dive.
We'll see you next time.